This is a recap for Wednesday, March 17th. So we worked on Cami page 4 and 5 today. So the target is understand and answer questions about graphs. So we kind of use the idea of a story, once upon a time. So once upon a time in our story starts right here. Time is this direction, so this is in hours, going from once upon a time, which means time zero, to, in this case, 11 and a half hours. And also distance. So distance is moving to this direction, and the units are in miles from home. So this means 20 miles from home, or 40 miles from home, or 60 miles from home. So the story starts with Liz, and she is 0 miles from home, which means you're at home. And so that is the ordered pair, 0, 0. So 0 from, at time 0, 0 miles from home is what that means. 3 hours after leaving home, she was 150 miles from home. So we didn't do the rate. We didn't do that on this problem. She just went to Aspen and it took her 3 hours. So we used in class a lot the line tool to show the two ways that we're thinking. This goes to the 3 and this goes over to the 150. So we have to think about both of those, both 3, which is the first number, that's hours after the beginning of the story, and 150, which is miles from home. And then it doesn't really say what happened here, but for some reason Liz stayed in the same place, or at least didn't get any farther or away from home or closer to home for the next 6 hours. So that's from hour 3 to hour 9 is 6 hours. So Liz remained at 150 miles from home until hour 9. So then that's the point, 9, 150. Then she started moving again. And so her return trip took a total of 2.5 hours. And we know that because it started down here at 9 and it finished right here at 11.5. So the finishing coordinate plane was hour 11.5 and 0 miles from home. So we can read these ordered pair as kind of part of the story. And this one is the end of the story. Right there. And right there. And this is the beginning of the story, once upon a time, which is right here. So I'll leave that. Let me zoom out a little bit for you. In case you want any of those answers. Next, we looked at Tamira riding a Ferris wheel. And again, I'm going to zoom way in. And one thing we talked about was, the question is, which of these graphs would represent her height off of the ground at any particular time? And so you might want to stop the video right now and choose A, B, or C. Okay, so you're coming back. And what we can do is just look at time and height. So this is kind of like getting on the Ferris wheel. And the problem with this one is right here, or really any of these places, where as I go up, if I pick any place in time like this, like let's say I just pick that, and then I look up this direction, I've got 1, 2, 3 different places that Tamira would be in height off the ground. And we can only be at one place in one time. So this one does not work because it requires Tamira to be in 2 different places at once, which is impossible. This one looks okay, except for it starts on the ground. which a Ferris wheel does not, you're not sitting on the actual ground. So it starts out okay, it goes up in height over time. So as we go this direction, it goes up like this. But then this one might be that the Ferris wheel was broken down for a certain amount of time because it wasn't getting higher or lower. And a Ferris wheel is always either getting higher or lower to closer to the ground. And then it finally came back. So this is like a broken Ferris wheel, maybe. So that one can't be it. And then finally this one, as we're going to zoom way in here. And we're going to take some of these lines and just, here's a certain time. If I go straight up here, and here's a certain height. And if I go a little bit later in time, I'm a little bit higher. And then at some point, I'm as high, I'm at the peak of the Ferris wheel, and I go a little bit later, and I start to come a little bit lower until I get down to my low point, looking over at time like here, and then it goes around again. So I'm coordinating these ideas of minutes in time and height, and this one just keeps going around 3 times until it ends right where it begins. So if I kind of think about this height right here is the same as this height, so they can get off. All right, so the answer in this case was C. And then we went down and did the next 2 problems. Viviana walked for an hour at a constant speed. Sketch a graph that shows her speed. This doesn't have any numbers, and you don't really need any numbers. To just pick a speed, and then that speed can't go up or down. It has to just be flat, so we'll just leave it like that. And her distance is at 0 minutes, and then over time the distance just keeps increasing for an hour. So that's what those 2 graphs would look like. Tyrone is 8 miles from home. And the reason I know that is because at time 0, at the beginning, he's at a movie theater, and that movie theater at the beginning is 8 miles because this scale is distance from home. It took him half an hour to get home. That's what that means right there, 0.5 hours. And so that's 8 miles in 0.5 hours. And we can multiply. We can divide by 0.5 or multiply by 2. We get the same results. We'll just double this and get to 16. So he went at 16 miles per hour to get home. He was at home for 1 hour, not doing anything, maybe getting ready to go. It's not really in the question here. But then it says, what's his rate of speed from home to the gas station? So the gas station is 4 miles away. And we can look right over here at this 4. And it points right to it like that, looking in that direction. So we went 4 miles and took 15 minutes from 1.75 minus 1.5 is 0.25. I'm getting the 1.75 for that time right there. And I know he left and started getting farther away from his house at 1.5. So just subtracting those 2 gives me the 0.25. So 4 miles in a quarter hour is the same speed, is 16 miles per hour. If we multiply those both by 4, we get 1 hour. So find the rate of speed in miles per hour for the trip home from the gas station, from home to the gas station, is also 16 miles per hour. And you can see that the graph looks like the same steepness. This is kind of symmetrical from here to there. And how long was he at the gas station? He was there from 1.75 till he started moving again at 2. And that's equal to 0.25 hours, or 15 minutes. A quarter hour is 15 minutes. And then how long did it take Tyrone to get from his house to his friend's house? So that's this 1.5 to the 2.5. And how do we know it's at 2.5? Because if we look up right here, that's going to tell us that he's arrived. And he's arrived at his friend's house. That's the end of his the story. So that's the finishing distance from home. So how long did it take? Whoops, it took 1 hour. And that's as far as we got in class. And then we worked on Pear Deck, which we'll continue to work on. I'll take a look at those. But this is a recap for Wednesday, March 17th.